Okay, today, the last the last challenging thing to know before we get into reviewing for the test, because actually we've gone faster than we needed to, which I know meant the last couple of days were really intense, but I am going to trade that out by having 2 review days. Monday and Tuesday are going to review, and then Wednesday's the test. That's the current plan. Some kids were asking if Tuesday was the test. No, Wednesday's the test. I know at one point I said Thursday. Bottom line, you have after today 2 days of review and then the test. So what's the last thing I have to teach you? I'm going to do that in a minute after we review. Okay, so I'm going to throw in a little quiz here that kind of covers the main things you're supposed to know so far. All right, inverse trig. Just a quick reminder, inverse cosine's only allowed in 2 places. Inverse tangent in 2 places, and inverse sine in 2 places. Would you please find the 3 sine, cosine, tangent? Tell me where they can be. Do things like this. That's inverse sine, except it's not. Okay. Write this one down. This isn't the part of the quiz. This is just me kind of reminding you of a few things you ought to know. Okay. Should have said inverse cosine from here to here. Raise your hand if you had that one right. Okay, that one's where you could do inverse cosine. Next is these two are kind of similar. Notice this one's not touching. This one is going to touch pi over 2 and negative pi over 2. Which one touches and can be pi over 2 and negative pi over 2? Yes. Yes. Sine's the one that touches because sine doesn't have what's? Asymptotes. And the red one there is tangent. Inverse tan is allowed on that side and can't touch at those 2 spots. All right. Ready? Here's the typical mistake. Somebody's gotten all done and has figured out an inverse question that ended up putting them there. I'll give you an example of one. Would you agree that it would have to be either inverse sine or inverse tangent? Okay. And so let's say that it was inverse tangent and the thing was negative. Like that. Finish that problem and tell me what the answer is. And this is something unique to inverse trig. So be careful. Remember, just because it only looks like I gave you one side, I actually gave you 2 sides. What could you do to make it more clear that I gave you 2 sides? Put it over 1. Like that. Or put in another 1. Yes. That's smart. Can you tell me what sides we would have? Across from the central angle, you can use the words like opposite, hypotenuse, adjacent. The adjacent is 1. Okay, you're right. Good. Yes. Excellent. And then what type of angle then must the central angle be? All right. So give me your final answer. Do you think you'd want to put 45 degrees on the test as your final answer? No. What would you put? Ooh, not only is it negative 45, very good, you also changed it to negative pi over 4. Do you get that it's really common for people to forget that that's a negative angle? The other mistake is they'll go, oh, so it's a whole bunch of pi over 4s, 6 pi over, no, what would it be? 7 pi over 4, if you could do it that way. But you can't, because it's an inverse trig question. All right, last thing, what's especially dangerous about this quadrant? Dead zone, nothing works there. And you can't go past pi. If you ever find yourself giving an answer like 7 pi over 6, anything past pi is wrong. Even if you're thinking you're getting here by going past pi, you're wrong. If you're doing inverse trig. But some of the questions on our test are inverse and some of them aren't. All right, next kind. I want to remind you, it's not the tangent, let's do, how in the heck could the cosine of something have come out to 0? The side is 0? Oh, it must be at a quadrantal, it's called. At one of those 4 spots like 0 or pi over 2, etc. Would you please figure out this answer? Is it inverse trig? Yes, it is, because it's got the little -1 on there. And therefore, does it have restrictions? Yes, it does. Okay, so you should know you can only be from here to here, so this is out and this is out. And then you should be thinking, well, it's probably here or here or here. So I'm going to refresh my memory on this. I think it's 1, 0, 0, 1, and -1, 0. And then y is, well, I'd like to say it this way. Sine is y, cosine is x, and tangent is y over x. Okay, so if this is cosine, it's x, and it's asking where is x 0. Looks like that's the spot. What do you think the final answer is? Pi over 2. How many of you think it's pi over 2? Raise your hand if you think it is. Okay, awesome. And you are right. How many answers should there be for a inverse trig question? Only one answer. Okay. Are there other types of problems where you can have 2 answers? Yes, they just aren't inverse trig questions. All right. And we did one the other day that was like that, where it was like, oh, let's go sine of some, not inverse sine, it was sine of, I don't know, let's do like 5 theta, we'll make it more interesting, equals 1 over 2, let's just do that. Okay, if you had to do this, what's step 1? Let 5 theta equal u, or let u equal 5 theta, either way. And then you put a u in here. And then it's a much easier question. You've done this one a whole bunch of times. In fact, I got it memorized. Sine of what is a half? Sine of 30 is a half. And so it must be 30, except we like to use radians, so pi over 6. But is there another answer? Yes. Okay, so eventually you end up realizing that this is pi over 6 is one of your answers, and the other one's 5 pi over 6. If you don't know how to do those, then you're pretty much toast on this test. Because now that isn't the answer. That's just the beginning of the answer. Pi over 6 and u equals 5 pi over 6. Now we have to do that whole, but it isn't really u. We got to replace the u with what? 5 theta, 5 theta. And then what do I have to slap on here to generate more terms? Because I'm going to need 10 answers. I'm not going to do all of them, but plus 2 pi k. And yes, we're going to divide it, or we're going to multiply everything by 1/5. I would just do it in the course of doing this, because I'm solving to get the 5 off the front. And now it's theta equals pi over 30 plus 12. No, that's the times. 1 times 2, so 2 pi over 5. And that doesn't work nice, so then I'd multiply everything by 6 so that I get a common denominator. Would you just tell me the first 2 answers you'd get out of this? It's not really pi over 6 anymore because we had to multiply by 1/5. So give me the first two answers. That'll prove you can do this process. Sure. Okay, so then you're going to let k equal 0. And if k equals 0, this part right here equals 0. If k equals 0, then this part disappears, and you just have pi over 30. Raise your hand if you had pi over 30 as the first one. Okay, that was the easy one, because we didn't need common denominators or anything. But if I put in k equals 1, and I put a 1 here, and then I have 12 pi over 30. So now I'm going to clean this up here. I have pi over 30 plus 12 pi over 30, and that will give me my next answer, which I believe is 13 pi over 30. Anybody confirm they got the same thing without me? Maybe I screwed it up. Oh, it's 1 times 2. Thank you. It's 1 times 2. It's not 12. Ugh. 2 pi over 30. Sorry. That got so messy in there. That was a 1 times 2 pi. So that makes 2 pi over 5 times 6 on the bottom. That makes 30. There we go. I see this happen to kids all the time on their tests. They get too messy and then they can't read their own writing. And I did it to myself. This one was pi over 30. And this one's 2 pi plus 1 pi makes 3 pi over, I think. 2 pi. I think it's right now. I could reduce it, but question? Oh boy. Okay, gotta go back in time. I do the circling and stuff to try to help, but then it makes it really messy. Let me get it back to this. Okay. It is pi over 30. To make it a common denominator, there was a 6 there that I couldn't even see because I'd drawn over it. Thank you. 6 times 1 times 2 is 12 pi over 30. It is 12 pi over 30. It's not because it's a 1 and a 2, which is what I thought in the first place, but it's because there's a 6 times the 2, so it is 12 pi over 30. So, sorry, pi over 30 is my first answer, and then I'm going to keep adding 12 pi over 30 until I get all my answers. So 13 pi over 30 was actually right, but for the wrong, I had it for the wrong reasons. But. And then what do we keep adding? 12 pi over 30. So if I'm going to do another one, I am going to get 12 pi more than that. So then I got 25 pi over 30. And that seems like it's just about to go over 2 pi. No, it's just about to go over 1 pi. 25 30ths is still less than 1. So I could keep adding 12 pi a whole bunch of times. That's why you get so many answers for this one. Okay, so be careful. One of the things I see people do is they try to make it small when it can be big. Like you've got unlimited virtual paper on your iPad. You know, if you try to write too small, or if you get too messy, stop and rewrite. I should have stopped and rewrote earlier, and I might not have gotten so lost with, I forgot my 6's there because I couldn't see them anymore because I wrote over them. Okay, so there's the beginning of your answer. I don't want to do the whole thing because that's part of your job on your quiz. So, one last kind we haven't talked about is the nested kind where you have parentheses. We'll do one more of those. Yes? Good question. If it's tangent, then you are correct that you'd have to be careful about what you'd add, because you're right that tangent's period is pi. And so you'd want to factor that in. You're absolutely right. Very good. So I never tell you what's on the test. You're right that if you have tangent, you got to remember that tangent's period is pi, not 2 pi. So to get new answers, you don't keep adding 2 pi, you keep adding 1 pi. All right. Okay. So last kind I wanted to practice before you get going here is, what if it's tangent of cosine of, let's do one we already did. So you start on the inside, figure out that answer, and wait, we already did that one, didn't we? We did one like it anyway. And then when you're all done and you got your picture drawn, you do tangent. Pause for a second while you give that a try. Next thing in class, I'm handing around this sheet. It's the sheet that you got on your last test of identities. There's a one question where you'll need this on tonight's homework. Actually, there's two questions on tonight's homework. And you'll need an identity sheet for your test again. Is it a proving test? No. Okay. But there's substitution involved. Like, you know, you pull something off the sheet and put in something else. All right, so what the reason I'm handing this around is some of you are going to, I had an idea and I kind of like it. What if you take a picture of this and it just stays on your iPad, and then whenever you don't have to try to find it in Schoology, you can just look back at the pictures, okay? So I'm going to recommend you take a picture of this sheet and then hand it back to the next person, and they can take a picture of the sheet. If you've already got the sheet, great, but you're going to need it for tonight's homework. So if you don't have it handy, take a picture of it, okay? Take a picture, hand it on to the next kid. And the reason I think that's better than just having it, I already did post it. If you really wanted to, you could go find it, but it's going to take you like 5 clicks in Schoology to try to find last chapter, find it, open it. If you want to do that instead, that's totally fine with me. Okay. Inverse cosine only allowed from here to here. That's out, that's out. And this is that one where cosine is the x. This one's at 1, 0. This one's at 0, 1. And this one's at -1, 0. And then I quickly figure out, since cosine's the x, that it's this one. And so then it's, what is the answer? Pi over 2. But, big but, tangent of pi over 2, what's special about that? Do you remember me obsessing about how tangent can't touch? Tangent can go from here to here, but it can't touch there, and it can't touch there because of the what's? Asymptotes. So therefore, it's outside the zone that it's allowed. Therefore, it's no solution. Another way to say it is this. What's the tangent of pi over 2? Well, if I look at the graph of tangent, here's pi over 2 right here. It's an asymptote. There's nothing there. There's no solution. So the final answer to that one was no solution. I know some of you might have thought, well, then the tangent's y over x, so it would be 1 over 0. But what is 1 over 0? No solution. Can't do that. And that's another way to say that answer. Okay, enough practice. Now here's your little in-class homework quiz. This is going to count as homework, not as a test score. And it's right here. 3 little questions. I am going to add 2 more just for the people at home so they can see. But these 2 I'm not grading. So problem 4 is -2 cosine theta equals square root of 3. I wouldn't be doing it if it wasn't important. But I don't feel like it's fair because we've never done one like it. And I don't feel like it's fair for me to grade you on it right this second until we've done one like it. But most kids figured it out. But there's a twist. Okay, and then number 5 that I think you should do, but again, it's so different than what we've done lately, I don't want to put it in your grade yet, is, do you remember how to solve a quadratic? There's a quadratic. Solve it. It'll help you remember that, because today you're going to be factoring trig. First, you better be able to factor with normal variables. And hint, if you're like, I don't know how to factor that, get it rearranged like you do with every quadratic. First you rearrange it, and then if you can factor it, you should. All right, I'm going to pause for a minute. You need to answer 1, 2, and 3. 4 and 5 are kind of like, I hope you can do them, but I'm not grading you on that. Okay? And number 1, sometimes people freak out like, I don't have this triangle memorized. you don't have to have the angle for number one, because in the end I want the sine of the angle. So you won't need to know what angle that is. Pausing. Here we go. So we're going to go back and grade that quiz at the end of the hour and kind of have the lesson in the middle here. So here's the lesson for today. Do you remember this one? I told you that it was likely you'd see that one again on the AP tests and you probably should know it. Do you have this one memorized yet? If you don't, you could look it up on the chart. Say it again. 2 sine cosine. Good. 2 sine cosine. So if you know the angle, is like 30 degrees, then 2 times the sine of 30 times the cosine of 30 would give you the answer. Okay, that's one that you have memorized. Yay, some of you. And I said when we have like sine of 3 theta, we have to do it this other weird way where we do a u substitution and we say let that be u for a while, and okay, right? You remember that? But what about cosine of 2 theta? That's one that you don't see very often. It's on the sheet. And I just sent the sheet around so that people could like take a picture of it if they wanted to. Look up near the bottom of the sheet, in the bottom right-hand corner. It's got 3 things that could be substituted for that. And you have to choose logically, when to use what? Cosine squared minus sine squared. Or you could put in 1 minus 2 sine. Or you could put in 2 cosine squared minus 1. Well, when do you use what? Here's the moral of the story. Typical question. You have cosine of 2 theta in a problem, and you have the sine of theta in a problem. Do you get that if I have a choice of what to put in, I'd like to put in something that kind of matches the sine and only has the sine in it? That means the middle one. Why? Because now I got it down to only one function, sine. And what's good about that? You should have learned by now to take quadratics. What? Just because there's a little squared there means it's quadratic? Yup. Quadratics. And then you should be able to rewrite them into factored form. I'm subtracting sine from both sides. Once I'm done, I think you'll see why I did that. It equals 0, and I have negative 2 sine squared theta minus sine theta, and that's a positive 1 at the front, right? Plus 1. That doesn't look like it'd be very nice to factor. What I could do is factor out a negative 1 at the beginning, and then it's 2 sine squared theta plus sine theta minus 1, and then it will factor. Two sine. Can you factor it? I showed you how to get there. Can you finish the deal? Try factoring that. Because if you can factor it, you should. So often, the toughest problems, haven't I said this before? The toughest problems come down to factoring. If you once you realize, oh, I could factor it, then it makes it easy. That's probably been 8 times this year so far, where this is the nastiest thing. It's the last thing I'm teaching you. Then after this, it's all review. And what does it boil down to? Doing a substitution first and then factoring. All right. Well, obviously, we have to have 1 plus and 1 minus. But it's got to be a 1 times 1 to make it equal 1. And then one of them needs to be positive, one needs to be negative. Otherwise, it wouldn't be a negative 1. So I'm just going to try it this way and just see if that works. Outside, then, would give me positive 2 sine theta. Inside, negative 1. Put them together, that's positive 1 sine theta. And that's what I wanted. Sweet. I got it all factored. Can I be done now? Nope. Because it's factored, but I don't have the answers. So you take this, and guess what? After all that work, you've got a new problem. It equals 0. You set this one equal to 0, and you set this one equal to 0. Do you set a -1 equal to 0? No, that's impossible. So you don't worry about the last one. But I'm going to set this equal to 0, and does that look, after I subtract 1 from both sides, like one of those questions that we've had recently? And you get 2 answers for it because you draw your triangles in the right places, and holy man, that's intense. But what it boils down to is you do a key substitution at the beginning. At cosine 2 theta, you can look it right up on the sheet, is 1 minus 2 sine theta. And then I just rearranged it until it was all on one side and equal to 0. That's what you do with any quadratic. And then I factored it. Yay, I felt like I was done, but I wasn't, because then I had to break each piece and set it equal to 0. And then at the end, how do I finish this thing? Well, where is sine -1? Sine is the y, and so I find the spot on the quadrantals where that works. This is 1 comma 0. That doesn't have a -1. This is 0 comma 1. That doesn't have a -1. Maybe I should just go where there's a -1. Oh, that's these two spots. -1 comma 0. Is that the right place? No, because we want the y. Sine is y, right? So then it's that spot. Is inverse sine even allowed down there? Well, wait a minute. Was there ever an inverse sine in this problem? There was never an inverse sine in this problem. So you don't have to worry about that. Okay. So then it's that spot. Because why? Because the y is -1 and sine is y. And it's that spot. And what's that spot called? After all that work, the kid writes down 3 pi over 2. And is that right? Now, some of you are thinking it should be -pi over 2. So there's team -pi over 2 and there's team 3 pi over 2. Which team are you on? Hannah? Since there was no inverse, it's 3 pi over 2. All right. Usually, you'll have to choose that. You'll be like, oh, should I say this is negative? Because Mr. Server made a big deal about this quadrant being negative down here. For inverse trig, but this isn't inverse trig. We never did any inverse sine in this process, so there's no restriction on a problem like that. So bottom line, this can be 3 pi over 2. Okay, all right. There's a way to even make this more complicated, believe it or not, but that's bad enough. Steps: swap something from the list so that you can factor, set it equal to 0, and then you can factor it, and then you can take each side and set it equal to 0, and then you can do one of these things for both sides. I'm not even done yet. I have to take this one and set it equal to 0. And then I have to figure out where sine is positive and go to those 2 spots, and there's 2 answers for that one too. Whew. All right, so moral of the story, use the sheet to swap something in so that you can factor it. And you have 3 questions like that for your homework for tonight. Pause for a second, see if I can find those. So here I found it, and I've even got some help for you. You're going to do 23 and 27. 23 is just like the one I did on the board. So if you watched me do all of that, well, then you don't have good notes. If you took notes, yay for you. You've already got problem number 1 mostly done. And here's the second problem. Should I swap out the cosine of 2x? Yeah. Choose strategically what to put in there. Oh, actually, I'm sorry. Number 23 is not exactly like the one we did in class. So if I were you, I would get started with me. So find your homework. It's a file called 15.2, day 2. 15.2, day 2. I'm only assigning you 3 of them. And the first one is partway done. I did a substitution But this time I used cosine. Why do you think I used cosine? Because there was already a cosine in the problem. And that made it match. Now there's all cosines. And the same exact kind of thing happens, except they're all cosines instead of being all sines. Once you get it factored and set equal to 0, then you take each part and set it equal to 0. I haven't gone as far here. I haven't actually taken this guy and solved it and then figured out where cosine is 1. Quadrantals come up a lot in these. All right, on number 27, which is the second problem I'm having you do, replace this with something off the sheet that matches. What's the rest of the problem got? Sines. So maybe you should use the one that has sine in it. There's 3 choices on the sheet. Okay. And then last but not least, we're going to go to this page where cross off 33 and just do 25. I think if you did those 3 problems, you would be well prepared. Once again, it's got a cosine of 2 theta. On this kind, you want to replace that off the sheet. Choose the right one of the 3 so that this will factor. Once you get it factored, it's already set equal to 0. It's another hint that it's probably one of those kind where you factor it. Once you get it factored, solve each side for 0. You usually get 2, 3 answers for these, sometimes 4. Okay. And now, to go back to that quiz, I want the kids at home to see the answers for those 2. So I'm going to pause for a second while we grade that, and I'll put them up. Okay, number 1. Arc cosine. Okay, don't put your iPad away. We're still grading this right now. Okay, good. All right, so we're going to have a triangle, and in its inverse cosine, so it's only allowed here and here, crossing off these. And that means of the 2, we're going to use the one that's positive, which is right there. And then this is cosine is adjacent over hypotenuse, and this is 12. And then you should have done sine of that. Sine is opposite over hypotenuse, 12 13ths. Raise your hand if you had 12 13ths. Awesome. Now, the way we're grading this is out of 10 points. If you don't ever mark anything wrong, you'll have a 10 out of 10. I'll tell you what each thing is worth. On this next one, this one was, where is tangent or inverse tangent allowed? Only from here to here. And let's see, inverse tangent being 0, tangent being 0, it's either here, here, or here. And which one has the y over the x equaling 0? That one. And so your answer is 0, or 0 degrees. 0 would imply 0 radians. That's fine. 0 degrees is the other answer. So either 0 or 0 degrees for this one. Okay? And I don't want to keep you after too long, so I'm going to stop. We will grade this one tomorrow in class. And that's all I have. Sorry. Yes. Next class period. I think as you guys leave, I'm going to finish the video for the kids at home of how to grade that one. Have a good day. All right, so I'm going to replace this with u. It's going to be sine of u equals -1/2. And then I'm going to solve this and find the 2 places where sine is negative. And all students take calc, so these are the places where sine is positive. That means I'm down here. And sine is opposite over hypotenuse. And this is 30, and so also known as pi over 6. Therefore, that is 11 pi over 6. And the other answer was over here, and that one is 7 pi over 6. So my 2 answers appear to be 7 pi over 6 and 11 pi over 6. But then I have to remember that u really isn't what I have. I have 2 theta. So it's 2 theta and 2 theta. And then I'm going to go plus 2 pi k plus 2 pi k. You guys need to stay quiet because I'm recording right now. All right. And we're going to now solve this thing and multiply everything by 1/2. And that brings us down to theta equals 11 pi over 12. 2 times 6 is 12. Plus, and then the 2's cancel here. And I'd have pi k. And on the top one, I'd have 7 pi over 12 plus 2's cancel, pi k. And then, since I need 4 answers because this had a 2 theta in there, my first answer is putting in k equals 0, and I get 7 pi over 12. So 7 pi over 12. Then I put in k equals 1, and then I'd have this one is, let me think, 7, 12 pi over 12. So I got to add 12 pi over 12 to the 7. I'll make 19 pi over 12. And then there's this one, which is 11 pi over 12. And then the last one, which is putting in a 1 here. And then that makes 12 pi over 12 plus the 11 is 23 pi over 12. And there's my 4 answers for that one for the kids at home. All right, that's all I got for you for today.